Hello everyone, this is a video lecture for Calculus 2, section 11.11. It's the last section we have in Cal2, Taylor applications. There is just doing more Taylor stuff, so that's what we're going to do. Sometimes they're going to ask for a little bit weird stuff here once in a while, and of course we'll talk about it as we get there. So we got f of x is equal to cosine x. They say that c is equal to pi over 2, thus it is Taylor's, and they want find t3. What they're trying to get at is we're going to go to the third derivative, and so f prime is going to be a negative sine of t, or x, sorry. Second derivative is a negative cosine, and finally triple prime is coming back to a positive sign. And now I need to plug in the pi over 2 into each one of these. If you plug in the pi over 2 here, so f of pi over 2, and I'm going to try to do it, straight up right here instead of on the side. So when I plug in a pi over 2 into this guy, I'm saying 90 degrees. What's my x value there? And it's a 0. My f prime at pi over 2, what's your value at sine of 90 degrees is 1, but there's a negative, so a negative 1. Anything with a cosine should cancel out, and then with a plain old sine, you'll get a positive 1. So those are these coefficients that we'll be using in our sequence here. F of x is equal to 0, right there, plus a negative 1 divided by 1 factorial. Again, you don't have to do that, but I'm just making sure. X minus pi over 2 to the 1 power. 0 again, I don't have to write the rest of it. And then a positive 1 over, this was a 1, 2, and now a 3 factorial, x minus pi over 2 to the 3. That is the entire answer here. You can, you need to simplify. You don't need this. You make this into a 6, and then that's it. You're done. Like, type that in. That's it. I don't know what else to say. There you go. So, yay! There's a graph, I guess, that they're wanting with this. I have a graph here as well. And at pi over 2, we have this, and the cosine graph, the original, does something like this at pi over 2, and our polynomial, it does something kind of like this here. It's not the best, but there you go. Something kind of like that, so it's approximating it for some kind of zone in there. Yay! Smile face. Next question. We got 11,015. F of x is equal to x, not cubed, it's to the 1/3, so the cube root. C equals 1, n equals 3, and it gives me this little range domain, that's a domain I guess, between 0.9 and 1.1. We'll talk about that here in a little bit. Right now we're going to just focus on getting the third derivatives and all that kind of stuff. So start with my original. Go ahead and just plug in your 1 while we're here, and you get 1. Pretty easy there. Your first derivative, the 1/3 comes to the front, negative 2/3. When you plug in a 1, you get 1/3. Go figure. The negative 2/3 comes to the front, making a negative 2/9. Now to the negative 5. I think it's 5/3. Verify. Yep. And of course now, when you plug in, second derivative, when you plug in your 1, that goes away, and you're left with the coefficient in the front. And the last one, because it said go to 3, this is my third, the 5/3 comes down here. So we got, what, 2 negatives make a positive, 10, and then 3 and 9 make a 20. Actually, hold on. Why do I have an 8 on mine? Yeah, and then I have a 10. Huh, that's so weird. Okay, my notes are fine in just a second. I just rewrote them weird. It's a 10. And then we got a 27 right here. 2 negatives make a positive. X to the negative 8/3. And so, just like always, if you're going to plug in your 1, you get the 10 over 27. So these are my coefficients. Start listing it out. Here we go. I got 1. I got 1/3 divided by 1 factorial times x minus 1 to the 1. I've got -2/9 divided by 2 factorial times x minus 1 squared. And I got 10 over 27 divided by 3 factorial x minus 1 cubed. All right, that is your answer. What they are now wanting for like part B, they say find R3. Find kind of like the remainder, the error, I guess you could say, that we're trying to find for the next term. I don't know. The formula for this particular one is that we're using the fourth derivative right now of x, 4 factorial x minus 1 to the fourth. This is always equal to the next term. And so we'll be using this a couple times in this section. But like notice we stopped at 3. So then what's my error, I guess you could say, is the next term, which is a 4. Okay, we can do that. So then like what's my fourth derivative? Just doing it again. So the 8/3 comes to the front. And I'm not going to play around with this. We actually got 10 over 27, -8/3, x to the -11 over 3, all divided by 4 factorial now, right there, x minus 1 to the fourth. And now the x is interesting. The x is going to be one of these guys, whichever maximizes your remainder, your error, I guess you can say. So we're going to plug in x equals 0.9 or and, I guess you could say, or 1.1 and see which one's the bigger one. Well, I plugged in the x equals 0.9 and it worked. I guess that was the bigger one. Maybe they're the same. I can't really remember. But I got a -0.000. Oh man, hold on. 0, yeah, 0, 605,579. So I just took this 0.9 and I plugged it in right there, and I just and right there, yes, and right there. And I got this. And so they want the absolute value of it, technically. And so your final answer is actually 0.0000606. And they accepted that. And I have a little thing here that says repeat a lot, because apparently you're going to have to do that a couple more times. Okay. Oh, man, this is one of my favorites ever. This is my favorite problem in this section for sure. Oh, yeah. So they say C is equal to pi over 2. T3 is equal to cosine of x, which is equal to negative x minus pi over 2 plus the 1/6 x minus pi over 2 cubed plus R3 of x. So they're saying there's a little extra remainder that we don't really know, whatever. And they're saying use this to approximate the value of cosine of 80 degrees. So you know what I did? I went into my calculator and I went into degree mode. Of course, degree mode, if we have degrees. And I just put in cosine of 80. And yeah, I got 17365. 5 decimal places is what they're looking for. Ta-da! I mean, this is just silly. Whatever. Yeah, you don't need to do this. Approximate the value of this. Well, I mean, I got a calculator that does it better, so whatever. 11,025. That was it. Whatever. It says use Taylor's to find out how many Taylors until, so how many, I'm going to say how many iterations of Taylors until e to the 0.1 is within 0.001 of the actual value. So in a way here, what they're saying is that we have this e to the x is that summation x to the n over n factorial. That's my e to the x business they're talking about. And we want this sequence, or the series, to be within Let me just go ahead and do this another time, plus blah, blah, blah. When we plug it all in here, we plug in x equals 0.1, we want it to be within this much of the actual value. Well, in order to know anything, we have to plug in the actual value. This is calculator, okay? And I got 1.10517. So this is what I'm comparing this against. I'm going to say blah, blah, blah. I plug in some stuff, and maybe I got a couple more terms or something. Like, do I have an x to the fourth? Oops. Do I need an x to the fifth? How many of these do I have to go until this equals that? That's my point here, okay? So how many do I need to go? And how I did this is I said, well, t1, like first derivative, I would just get a 1. What I'm doing is I'm just using the sequence, by the way, just right there, 1. T2, I'm going to plug in, again, this is all whenever x is equal to 0.1. I'm plugging in right here, 0.1, and so you get 1.1. T3, I'm now using these 3 right here, 1 plus the 0.1 plus the 0.1 squared over 2, and that got me 1.105. And what I'm going to do is say, you know what, these guys are pretty darn close, and so if you subtract them, it is within the 0.001 that they had originally said. So this guy is good enough compared to this guy. So the final answer is 3, because that was my last term that I used to make it work. Yes, I know what you're thinking. Couldn't I have just said 1, submit, no, 2, submit, no, 3, submit, oh, it worked. Yeah, but what if the answer was like 50? I don't know. Then you'd take a while. Okay. The last problem. This is actually the last problem in Calculus 2. Is it a good problem? Meh. So I got sine of x is kind of equal to x minus x cubed over 6. And they say my error is less than 0.01. Find the domain x values. Find domain. Again, I'm reminding you that means x values. So solve for x. That are within error. Within that error. Now, if you notice, the sign here actually is following the series that we had in the formula book, but it stops short. This one in particular stops short, and it stops at the 3. So I guess you could almost say it stops at the 4, because that would have been a 0 there. To find the error or the remainder, you would have to go, error or remainder, you have to go to the next term that's not 0. And so in this particular case, it would be x to the 5th over 5 factorial. And all I'm doing is following this sequence in here on here in the formula book. So we got a positive x, a negative. So the next one's we have positive over here, x to the 5th over 5 factorial. And then we got a negative, x to the 7th over 7 factorial, blah, blah, blah. It's just the odds. And so this is the one that I'm going to use because it's the next term. Okay, so I'm going to use this. And I'm saying that this guy here should be less than 0.001. That's my error. And I want to solve for x. I want to solve for x right here. And so how to do this? My 5 factorial comes over here to the other side. I think 5 factorial is just 120, but let me just verify real quick here. Of course, there's an error. 120, yep, just verifying. So I now have 0.001 times the 120 over there. Yes, everything is good here. And so I'm going to find a number there. So times the 0.001, and I got 3 over 25. Why did I get a smaller number? Oh, I know. Did you see it? I messed up something, didn't I? Look. 01001. Okay. That's a little better. Okay. So 120 times 0.01 is 6/5, and that now matches my notes. Okay. In order to get x by itself, I'm going to 5th root both sides, of course, And that got me the fifth root of 1.2, which is 1.037137. And so my answer, I guess 3 decimal places, is anything that's less, or is anything between this 1037 business. It says find a domain, so we're using parentheses and all that kind of stuff there. Ugh. Okay, whatever. Good enough. And we're done. We're done with all the Calculus 2 content. There we go. You made it this far. That's awesome. Thank you for hanging out with me this whole time. And thank you very much, and have a great day.